And swimming teacher for today, Sir Kim Anthony Frondozo from Valenzuela City School of Mathematics and Science, Grade 8 Enhanced Mathematics teacher. Join me as we discuss and learn mathematics today. I want you to listen attentively, focus on our discussion, engage in every activity throughout our session, and of course, have fun. Our topic for today is about systems of linear equations in two variables. Specifically, we are going to study the graph of systems of linear equations in two variables, the different methods in solving systems of linear equations, and problems involving systems of linear equations in two variables. So the learning competencies we are going to cover for today are illustrates a system of linear equations in two variables, graphs a system of linear equations in two variables, categorizes when a system of linear equations in two variables has graphs that are parallel, intersecting, and coinciding. Solve problems involving system of linear equations in two variables. Are you ready? Let's begin. But then I have a question. Do you still remember parallel lines, intersecting lines, and coinciding lines? That's great. Now, let's have a house tour activity. Look around your house where you can find application of parallel, intersecting, and coinciding line. I will give you 10 seconds for you to write down all the parts of your house where you can see parallel, intersecting, and coinciding lines. Let's begin. Okay, time's up. Now, were you able to see the applications of parallel, intersecting, and coinciding lines in your house? Good job! Now, here are some of my examples of the parts of the house where we can see some parallel lines. For example, the windows. Like in the picture shows it parallel lines. Stairs in our house also shows example of application of intersecting lines. And the clock in the picture shows the example of application of coinciding lines. Now, let's have a recall activity entitled React and Learn. Answer the following questions flash on the screen by clicking the correct reaction. Like, heart, and care reaction in our stream. I will give you 5 seconds for you to click your reaction. Are you ready? Here is the first question. Which of the following is a linear equation in two variables in standard form? For the like reaction, we have x squared plus y equals 4. For the heart reaction, we have y equals square root of x plus 2. And for the care reaction, we have 2x plus 3y is equal to 12. Timer starts now. Time's up. So the correct answer is the care reaction. We have 2x plus 3y is equal to 12. Did you get the correct reaction? Great. For the recall, the standard form of linear equations in two variables is in the form of ax plus by is equal to c, where a, b, and c are real numbers, a and b should not both be equal to 0, and x and y are the variables, and a should be greater than 0. Question number 2. Which of the following is a linear equation in two variables that has a slope of -2 and a y-intercept of 3? For the like reaction, we have y equals -2x plus 3. For the heart reaction, we have 3x minus 2y equals 6. For the K reaction, we have 3y is equal to 2x minus 1. Timer starts now. Time's up. So the correct answer is the like reaction. We have y equals negative 2x plus 3. Were you able to get the correct reaction? Very good. Now, the slope-intercept form is in the form of y is equal to mx plus b, where m is the slope and b is the y-intercept. For the last question, question number 3, find the x and y-intercept of the linear equation x minus 2y equals 2. For the like reaction, we have x-intercept equals 1 and y-intercept equals negative 2. For heart reaction, we have x-intercept equals 2 and y-intercept equals negative 1. K reaction, we have x-intercept equals negative 2 and y-intercept equals 2. Timer starts now. Time's up. So the correct answer is the heart reaction. X-intercept equals 2 and y-intercept equals negative 1. Now, let's recall intercepts. X-intercept is the x-coordinate of the intersection of the line with the x-axis, while the y-intercept is the y-coordinate of the intersection of the line with the y-axis. Did you get all the 3 correct reactions in our activity? Good job! Now, you are ready to move to our lessons for today. But before that, let us have some definition of terms. First is the system of linear equations. It is a set of 2 or more linear equations that are simultaneously graphed. When these linear equations are graphed, they show geometrical relations like parallel, intersecting, perpendicular, and coinciding. Second is the word solution. Solution of such equation is an ordered pair of numbers that satisfies both equations. And for the last word, we have solution set. Solution set of a system of linear equation is in 2 variables is the set of all ordered pairs of real numbers that makes every equation in the system true. Now, let us proceed to the different classifications of linear equation. First, we have inconsistent. So the graphs of the equations of an inconsistent system are parallel lines. So these lines are coplanar and have no solution. So here is an example of parallel lines. Take note that we need to put the markings, like the arrowheads, to indicate that the 2 lines are parallel to one another. Next, we have consistent independent. So the graphs of the equations of a consistent independent systems are intersecting lines. So these lines intersect at a common point and have one solution. So here is an example of intersecting lines. So the coordinate of the point of intersection of the lines is the solution to the system. Another type of consistent independent is where the graph of the equations of the system are perpendicular lines. So these lines are also intersecting lines and form a 90-degree angle in their intersection and have one solution. And for the last classification, we have the consistent dependent. So the graphs of the equations of a consistent dependent system are coinciding lines. So these lines overlap and have infinite solutions. So here is an example of consistent dependent. Now let's have some examples. Example number 1 is for us to identify if the following systems of linear equations are inconsistent, consistent independent, or consistent dependent. We have the equations 2x minus y equals negative 1 and 2x minus y equals 1. Now, for us to solve the given example, first we need to graph the first equation 2x minus y equals negative 1. Let's find the x-intercept by letting y be equal to 0. So we'll have 2x minus y equals negative 1. So by substitution, we had 2x minus 0 equals negative 1. So we'll have 2x is equal to negative 1. Dividing both sides by 2, so we'll have x to be equal to negative 1/2. So the line crosses the x-axis at negative 1/2, 0. So we will plot the coordinate in the Cartesian planes. We'll have negative 1/2, 0. Next is finding another point on 2x minus y equals negative 1. So we will need to solve for the y-intercept by letting x be equal to 0. So we'll have 2x minus y equals negative 1. So by substitutions, we'll have 2 multiplied by 0 minus y equals negative 1. So we'll have 0 minus y equals negative 1. Then dividing both sides by negative 1, so we'll have y to be equal to 1. So the line crosses the y-axis at 0, 1. So we'll plot the other point on the Cartesian plane. Then connect the 2 points. We'll form a straight line. And we'll name the line 2x minus y equals negative 1. So that is the graph of the first equation. For the second equation, we'll do the steps in graphing the first equation. So we will graph 2x minus y equals 1 on the same Cartesian plane. So for the solution, we need to find the x-intercept by letting y be equal to 0. So we'll have 2x minus y equals 1. So by substitutions, we'll have 2x minus 0 equals 1. Then we'll have 2x equals 1. Then dividing both sides of the equation by 2. So x is equal to 1/2. So the line crosses the x-axis at 1/2, 0. We need to plot the point on the Cartesian plane. Next is to solve for the other point by finding the y-intercept. We let x be equal to 0. So we'll have 2x minus y equals 1. So by substitution, 2 multiplied by 0 minus y equals 1. We'll have 0 minus y equals 1, dividing both sides by negative 1. So y equals negative 1. So the line crosses the y-axis at 0, negative 1. Then we plot the other point on the Cartesian plane and connect the 2 points and name the line 2x minus y equals negative 1. And this will be the graph of the systems of equation. Another way of solving the given example is algebraically. Let us transform 2x minus y equals negative 1 into slope-intercept form. Y is equal to mx plus b. So we'll have 2x minus y equals negative 1. Then adding both sides of the equation, negative 2x, by addition property of equalities, we'll have 2x plus negative 2x minus y equals negative 2x minus 1. So we'll have 0 minus y equals negative 2x minus 1. So we'll have negative y equals negative 2x minus 1. Since y is positive in the slope-intercept form, so we divide both sides of the equation by negative 1. So we'll have y is equal to 2x plus 1. So we'll have our slope m sub 1 is equal to 2 and y-intercept b sub 1 is equal to 1. Now, let us transform the second equation, 2x minus y equals 1 into slope-intercept form, y equals mx plus b. So we'll have 2x minus y equals 1. Then by addition property of equality, we add both sides of the equation, negative 2x, to eliminate 2x on the left-hand side of the equation. So we'll have 0 minus y equals negative 2x plus 1. And we'll have negative y equals negative 2x plus 1 since y is positive in the slope-intercept form. So we divide both sides of the equation by negative 1. So we'll have y is equal to 2x minus 1. So our slope in the second equation is 2 and y-intercept b sub 2 is equal to negative 1. Now, let's compare the slopes and the y-intercepts of the given example. So if we are going to analyze, since m sub 1 is equal to m sub 2 and b sub 1 is not equal to b sub 2, so the graphs of the equations are parallel lines because they have equal slopes but different y-intercepts. And the systems is inconsistent and no solution. Now, let's have example number 2. Identify whether the following system of linear equations are inconsistent, consistent, independent, or consistent dependent. So our equations are 2x minus y equals -1 and x minus 2y equals 1. So using the graph of 2x minus y equals -1 in the previous example, so we will just graph it in the Cartesian plane. So we will just solve and graph the second equation, x minus 2y equals 1. Now, let's graph x minus 2y equals 1. So to find for the x-intercept, we let y be equal to 0. So we'll have x minus 2y equals 1. So by substitution, we'll have x minus 0 equals 1. So therefore, x is equal to 1. So the line crosses the x-axis at 1, 0. Now, let's plot the point on the Cartesian plane. Next is to find the y-intercept by letting x be equal to 0. So x minus 2y equals 1. So by substitution, 0 minus 2y equals 1. We'll have negative 2y equals 1. Then dividing both sides of the equation by -2, so we'll have y to be equal to -1/2. So the line crosses the y-axis at 0, -1/2. Plotting the point on the Cartesian plane and connecting the points. So this is the graph of x minus 2y is equal to 1. Let's solve the given example algebraically. So we'll have 2x minus y equals -1 and x minus 2y equals 1. Another way of finding the slope is by using the formula m is equal to -a over b. Since a is equal to 2 and b is equal to -1 in the first equation, and a is equal to 1 and b is equal to -2 in the second equation, then m for m sub 1 is equal to -2 over -1. So therefore, m sub 1 is equal to 2. Now, for the second equation, we'll have m to be equal to -1 over -2. So therefore, m sub 2 is equal to 1/2. Now, solving for the y-intercept in the second equation, x minus 2y is equal to 1, we just let x be equal to 0, so y-intercept is -1/2. Now, comparing the slopes and y-intercepts of the given example, since m sub 1 is not equal to m sub 2 and v sub 1 is not equal to v sub 2, but in some cases, it is possible that the system can have the same y-intercept. So the graph of the equations are intersecting lines because the slopes are not equal and different y-intercept. Okay? So the system is consistent, independent, and has one solution. Example number 3. Identify again whether the following systems of linear equation are inconsistent, consistent, independent, or consistent dependent. So for the first equation, we have 2x minus y equals -1. And for the second equation, x plus 2y equals 1. Again, using the graph of 2x minus y equals -1 in the previous example, so we'll just graph it in the Cartesian plane. So we'll just solve and graph for the second equation, x plus 2y is equal to 1. Now, let's graph x plus 2y is equal to 1. Solve for the x-intercept, so we'll let y be equal to 0. We'll have x plus 2y equals 1. So by substitution, x plus 2 multiplied by 0 equals 1. So we'll have x plus 0 equals 1. So x is equal to 1. So the line crosses the x-axis at 1, 0. Now, let's plot the point on the Cartesian plane. Next is to find the y-intercept. We let x be equal to 0. So we'll have x plus 2y is equal to 1. So by substitution, 0 plus 2y is equal to 1. Then 2y is equal to 1. Then dividing both sides of the equation by 2, so we'll have y is equal to 1/2. So the line crosses the y-axis at 0, 1/2. Plotting the point on the Cartesian plane and connecting the points, so this is a graph of x plus 2y is equal to 1. If we are going to use the protractor to measure the angle formed by the graph of the system, then it forms a 90-degree angle. So 2x minus y equals -1 and x plus 2y is equal to 1 are perpendicular lines because its intersection form a 90-degree angle. Comparing the slopes of the two linear equations, we'll have 2x minus y equals -1 and x plus 2y is equal to 1 by using the formula -a/b for the slope. So for m sub 1, we have positive 2. And for the second equation, m sub 2 is equal to -1/2. Since m sub 2 is a negative reciprocal of m sub 1, then we can say that the graphs of the equations are perpendicular lines because the slopes are negative reciprocal of each other. So this system is consistent, independent, and has one solution. Some examples of negative reciprocals. So we have -3/4 and -5. First, we need to get the reciprocal of the sample slope. So we'll have -4/3 and -1/5. Then get the negative of the resulting reciprocal. So we'll have 4/3 and 1/5. Next, example number 4. Identify whether the following systems of linear equations are inconsistent, consistent independent, or consistent dependent. So we'll have the equations 2x minus y equals -1 and 4x minus 2y equals -2. Again, using the graph of 2x minus y equals -1 in the previous example, so we'll just graph it in the Cartesian plane. So we will just solve and graph the second equation, 4x minus 2y equals -2. Now, let's graph 4x minus 2y equals -2. To solve for the x-intercept, we let y be equal to 0. So 4x minus 2y equals -2. So by substitution, 4x minus 2 multiplied by 0 equals -2. Then we'll have 4x minus 0 equals -2. 4x is equal to -2. Then dividing both sides of the equations by 4, then x is equal to -1/2. So therefore, the line crosses the x-axis at -1/2, 0. Now, let's plot the point on the Cartesian plane. Next is to find for the y-intercept. We let x be equal to 0. So we'll have 4x minus 2y equals -2. So by substitution, 4 multiplied by 0 minus 2y equals -2. 0 minus 2y is equal to -2. So we'll have -2y is equal to -2. Then dividing both sides of the equations by -2, so we'll get y to be equal to 1. So the line crosses the y-axis at 0, 1. Plotting the points on the Cartesian plane and connecting the points. So this is the graph of the linear equation 4x minus 2y equals -2. If we are going to look at the graph, the two lines overlap each other. Hence, the lines are coinciding lines. Solving the given example algebraically, transforming the second equation 4x minus 2y is equal to -2 into slope-intercept form, 4x minus 2y is equal to -2. Then adding both sides of the equation by -4x by APE, so we'll have 4x plus -4x minus 2y plus -4x minus 2. So we'll have 0 minus 2y is equal to -4x minus 2. -2y is equal to -4x minus 2. Then dividing both sides of the equation by -2. So y is equal to 2x plus 1. Therefore, m sub 2 is equal to 2 and b sub 2 is equal to 1. Now, comparing the slopes and the y-intercepts of the two linear equations, then we'll have m sub 1 to be equal to 2 and m sub 2 is equal to 2. And b sub 1 is equal to 1 and b sub 2 to be equal to 1. Analyzing, since m sub 1 and m sub 2 are equal and b sub 1 and b sub 2 are also equal, so it means that the graphs of the equations are coinciding lines because the slopes are equal and y-intercepts are equal. So the system is consistent, dependent, and has infinite solutions. Now, it's your turn. Directions. Identify the following systems of linear equations in two variables. Comment or type I for inconsistent, CI for consistent independent, and CD for consistent dependent. You have 10 seconds to comment or type in your answer. Are you ready? Here is the first question. We have x plus y is equal to 2 and x minus y is equal to 3. So timer starts now. Time's up. So the correct answer is CI. For the solution, finding the slopes of the first two equations, we'll have x plus y is equal to 2. So by using the formula and finding the slope, negative a over b, since a is equal to 1 and b is equal to 1, therefore, m is equal to negative 1 over 1. So m sub 1 is equal to negative 1. For the second equation, x minus y equals 3, m is equal to negative a over b, since a is equal to 1 and b is equal to negative 1. Therefore, m is equal to negative 1 over negative 1. So therefore, m sub 2 is equal to positive 1. Analyzing their slope, since the m sub 1 is equal to negative 1 and m sub 2 is equal to positive 1, so the graphs of the equations are perpendicular lines because the slopes are negative reciprocal of each other. So this system is consistent, independent, and has one solution. Did you get the correct answer? Awesome. Here is question number 2. 2x plus y equals 5 for the first equation and 2x plus y equals 2 for the second equation. So timer starts now. Time's up. So the correct answer is I. So for the solution, we are going to transform the equations into slope-intercept form. So 2x plus y is equal to 2. So the slope-intercept form is y is equal to negative 2x plus 2. So therefore, n sub 1 is equal to negative 2 and b sub 1 is equal to 2. For the second equation, 2x plus y is equal to 5. The slope-intercept form is y is equal to negative 2x plus 5. So n sub 2 is equal to negative 2 and b sub 2 to be equal to 5. So analyzing the slope and the y-intercept of the two equations, since m sub 1 is equal to m sub 2 and b sub 1 is not equal to b sub 2, so the graphs of the equations are parallel lines because they have equal slopes but different y-intercepts. And the system is inconsistent and no solution. Were you able to get all the questions correctly? Very good. Now remember, so for the different classifications of systems of linear equations, the graphs, the number of solutions, the slope, and y-intercept, for the inconsistent, we have a parallel lines, no solution, the slopes are equal, and the y-intercepts are unequal. For the second classification, we have the consistent, independent. So the graph can be intersecting, with only one solution, the slopes are unequal, and the y-intercept could be unequal or equal. And another type of consistent independent is the perpendicular graph, wherein the number of solutions is still 1, where the slopes are negative reciprocal, and the y-intercept are unequal or equal. And for the last classification, we have the consistent dependent, wherein the graph are coinciding and the number of solution is infinite or infinite solutions, and the slopes are equal and the y-intercept are also equal. Now, let's have our second topic about solving systems of linear equations by substitution and elimination. But before that, think about this. Analyze the given picture. For 5 seconds, I want you to know the value of what must be replaced in an apple for letter A and for letter B, a banana. So timer starts now. Time's up. So the correct answer is that an apple is equal to 5 and the banana is equal to 10. Did you get the correct value for each? Very good. Solving systems of linear equations, we have 3 different methods on how to solve systems of linear equations. First, we have by graphing. Secondly, we have by substitution method. And lastly, we have the elimination method. In our discussion earlier, we were able to graph and determine the number of solutions in a given system of linear equation. So we will just focus on the other 2 ways of solving systems of linear equations, by substitution method and by elimination method. Let's have an example. Solve the given system by substitution method. So we have 2x plus y is equal to 3 and x minus 2y is equal to 4. For the solution, step 1, we need to choose any from the 2 equations that will be used for substitution. Let's say x minus 2y is equal to 4. Step 2, solve for x in terms of y. So we'll have x minus 2y is equal to 4. So by addition property of equality, we add both sides of the equations by 2y. So we'll have x minus 0 is equal to 2y plus 4. So we'll have x is equal to 2y plus 4. Step 3, substitute 2y plus 4 to x in 2x plus y is equal to 3. So we'll have 2x plus y is equal to 3. So by substitution, so we will have 2 multiplied by 2y plus 4 plus y is equal to 3. By distributive property, we distribute 2 to 2y plus 4, so we'll have 4y plus 8 plus y is equal to 3. Then combining similar terms, we'll have 5y plus 8 is equal to 3. Again, by APE, addition property of equality, adding both sides by negative 8, so we'll have 5y plus 8 plus negative 8 is equal to 3 plus negative 8. So we'll have 5y is equal to negative 5. Then dividing both sides of the equation by 5, so we'll have y is equal to negative 1. So for step 4, solve for any of the 2 given equations using y is equal to negative 1. For instance, in x is equal to 2y plus 4. So by substituting the value of y is equal to negative 1, so we'll have x to be equal to 2 multiplied by negative 1 plus 4. Then x is equal to negative 2 plus 4. So we'll have x to be equal to 2. So it means that that solution is at 2 comma negative 1. Now, let us use the same problem, but this time let's solve it by elimination method. So we'll have 2x plus y is equal to 3 and x minus 2y is equal to 4. So for the solution, First, we name the two equations. So this would be equation 1 and this would be equation 2. Now, for step 1, we need to determine if variable x or y can be eliminated when the two equations will be added or subtracted. Since if we add both equations, none of the variables will be eliminated, then we proceed to step 2. We need to choose an equation to apply multiplication property of equality. So in this case, we choose equation 1 and multiply both sides by 2. So we'll have 2 multiplied by 2x plus y is equal to 3. Then simplifying, we'll have 4x plus 2y is equal to 6, which will be our third equation, or equation number 3. Now, it's step 3. Add equation 2 and equation 3. So we'll have x minus 2y is equal to 4. And we'll have 4x plus 2y is equal to 6. Adding the two equations will give us 5x plus 0 is equal to 10. So we'll have 5x is equal to 10. Then dividing both sides of the equations by 5, so we will have x to be equal to 2. Next, step 4. Solve for y in terms of the two equations using x equals 2. For instance, in x minus 2y is equal to 4, then we'll have x minus 2y is equal to 4. So by substitution, we'll have 2 minus 2y is equal to 4. Then by addition property of equality, we will add both sides by negative 2. So we will have 2 plus negative 2 minus 2y is equal to 4 plus negative 2. So it will give us 0 minus 2y is equal to 2. Then dividing both sides of the equation by negative 2 will give us y to be equal to negative 1. So the solution is a 2 comma negative 1. So it means that we can use any of the two methods and we will still arrive with the same answer. And for our last topic, we are going to discuss about solving word problems involving systems of linear equations. Now, let's apply all the things we learned today in solving word problems involving systems of linear equations into variables. We have different types of word problems where systems of linear equations are applied. We have the number problem, age problem, mixture problem, distance problem, and work problem. Since we don't have enough time, I will just give some examples of this word problem. For example, a number problem. We'll have the given problem as the sum of two numbers is 10 and their difference is 6. What are the two numbers? In solving word problems, we need to read, analyze, and understand the problem. After we understand the given problem, we will have now the representation. We let x be the bigger number and let y be the smaller number. Now, let's translate the problems into mathematical phrase or equations. According to the problem, the sum of two numbers is 10. So we'll have x plus y is 10 to be equal to 10. And their difference so we'll have x minus y is 6. So that will be equal to 6. So that would be for the given problem. So we can now solve the given problem. So for the solution, so the best way we can solve the given problem is by elimination method. Since if we are going to add the two equations, we can eliminate one of the variable. And in this example, we can eliminate y. So, x plus y is equal to 10 and x minus y is equal to 6. So this will give us 2x is equal to 16. Then dividing both sides of the equation, we'll have x to be equal to 8. Now, substituting the value of 8 to solve for y in any of the two equations. So for instance, we have x plus y to be equal to 10. So x plus y is equal to 10. So by substitution, 8 plus y is equal to 10. Now, by APE, we add both sides of the equation by negative 8. So we'll have 8 plus negative 8 plus y is equal to 10 plus negative 8. So this will give us 0 plus y to be equal to 2. So y is equal to 2. So the bigger number is 8 and the smaller number is 2. Let's have the checking. Is x plus y is equal to 10? So is 8 plus 2 is equal to 10? So by simplifying, we know that 10 is equal to 10. For the other equation, x minus y is equal to 6. We'll have 8 minus 2. Is that equal to 6? By simplifying, we'll have 6 to be equal to 6. For the second example, we have the age problem. According to the problem, a father is 4 times as old as his son. In 20 years, the father will be twice as old as his son. Find the present age of each. Did you read and understand the given problem? Very good. Now, for the solution, for representation, we can let x be the age of the son, and we can let y be the age of the father. For this type of problem, we can make a table to show relationships between their present ages and their ages in 20 years. So we'll have here the graph, the father's age, their present age. So according to the problem, so that would be y. So in the son's age is in terms of x. And in 20 years, the father's age will be y plus 20 and the son's age will be x plus 20. Now, let's translate the given problem into a mathematical equation. According to the problem, a father is. So that would be y is equal 4 times as old as his son. So that will be 4 multiplied by x. In 20 years, so that would be y plus 20 is equal twice as old as his son. So that would be 2 multiplied by x plus 20. So the equations will be y is equal to 4x and y plus 20 is equal to 2 multiplied by x plus 20. Analyzing the simultaneous equations, we had the best method we can use to solve the problem is by substitution. Since we can substitute 4x to the second equation, since in equation 1, y is equal to 4x. So solution, by substitution, substitute 4x to y is equal to y plus 20 is equal to 2 multiplied by x plus 20. So by substitution, this will give us 4x plus 20 to be equal to 2 multiplied by x plus 20. By distributive property of equality, we distribute 2 to x plus 20. So we will have 4x plus 20 is equal to 2x plus 40. Then by APE, we add both sides by negative 2x on both sides. So we'll have 4x plus negative 2x plus 20 is equal to 2x plus negative 2x plus 40. Again, by APE, we add both sides of the equations by negative 20. So we'll have 2x plus 20 plus negative 20 is equal to 40 plus negative 20. Then dividing both sides of the equations by 2 will give us x to be equal to 10. Step 2, substitute 10 to x in y is equal to 4x. So it will give us y is equal to 4x. So by substitution, y is equal to 4 multiplied by 10. So y is equal to 40. So the final answer is that the son's present age is 10 years old, and the father's present age is 40 years old. So in 20 years, the son's age is 30 years old, and the father's age is 60 years old. So by checking, we'll have y is equal to 4x. Is 40 equal to 4 multiplied by 10? So yes, 40 is equal to 40. Next, y plus 20 is equal to 2 multiplied by x plus 20. So 4 plus 20 is equal to 2 multiplied by 10 plus 20. So that will be 60 is equal to 2 multiplied by 30. Are they equal? Yes. So that would be the final answer. Now, let's have our generalization. So here are the steps in solving word problems involving systems of linear equations in two variables. Remember to read and analyze and understand the given problem. Then, represent the unknown using the variables. For step 2, we need to write the system of equation as illustrated by the problem. You may use the table to show the relationships of the variable. Step 3, solve the systems of equation by elimination, substitution, or graphing. Step 4, write and label the final answer. And for the final step, you need to check your answer. So I hope you enjoyed our discussion and most importantly, learned a lot today. Now, let's move to the next part, the Q&A or the question and answer part of our BAL Live. I will give you time for you to write or type in your questions in our comment section. So your time starts now. Okay, now let's read some of the questions in our comment section. We have a question here. According to the learner, is there any other way on how we can identify in a faster way if the given system of equations an inconsistent, consistent independent, or consistent dependent? Wow, that's a very good question. Actually, we can identify the classification of system of linear equations in a faster way just by analyzing. If we observe the relationship of the coefficients of x and y together with the constant term of the two equations. And I believe that your subject teacher will further elaborate on this. For the next question, according to the learner, is there any other method on how we can solve systems of linear equations aside from the three methods you discussed? Thank you for that very nice question. Yes, there is another way on how we can solve systems of linear equation, and it is by Cramer's rule. Cramer's rule is a method that uses determinants to solve systems of equations that have the same number of equations as variables. And you will discuss this in your next year level. So continue to study hard and move to next year's level until you finish your study. I hope you were enlightened and satisfied with my answer to your question. And for your home learning task, you may refer to the pictures given on the screen. So this would be your home learning task for this week. So to end our BAL Live session for today, I just want to thank you all for listening and actively participating up to the end of our episode. This is your Sir Kim. Have a blessed day and keep safe. Bye!